Every single day, 20 million barrels of oil travel through a strip of water just 21 miles wide. That is 20% of the world's entire oil supply, flowing through a single choke point that is 21 miles wide at its narrowest point.
Now imagine that choke point, closed, shut down, every tanker blocked. Overnight, oil prices spiked to one.
This is not a hypothetical. This happened in February 2026, and it forced engineers to ask the most audacious question in infrastructure history. What if you could build a $200 billion canal through 2,000-meter mountains to bypass the Strait of Hormuz forever? The Strait of Hormuz is 33 kilometers at its narrowest. The shipping lanes the set, just 2 miles wide in each direction.
Through those 2 miles pass the largest ships ever built. Very large crude carriers, each carrying 2 million barrels of oil.
Iraq, Kuwait, Qatar, the UAE. Every major Gulf producer depends on this single exit point to reach global markets.
Iran knows this. And for decades, every time tensions rise, the same threat is made. Close the strait, crash the global economy. The U.S. Energy Information Administration calls it the world's most important oil transit choke point.
Pipelines exist, but they can carry only 7 million barrels per day. The strait carries 20 million.
Which is why, in 2008, a radical idea emerged. And in 2026, after the strait actually...
The Hormuz Bypass Canal, a 950-kilometer channel linking the Persian Gulf to the Arabian Sea, 150 meters wide, 25 meters deep, large enough for the world's biggest supertankers sailing side by side.
For comparison's sense, the Panama Canal is just 7 to 7 meters wide. The Suez V, 300 meters.
The original plan envisioned a 180-kilometer canal from Dubai to Fujairah, crossing the Hajar mountain.
But here is where the engineering becomes staggering. The Musandam Peninsula, though the shortest crossing point, rises
To get a supertanker over a 2,000-meter mountain, you need locks. Not 1, not 10.
Each lock, 520 meters long, 80 meters wide, 30 meters deep, filling and emptying.
The locks alone would represent the largest hydraulic engineering project in human history, by a factor of 10.
Before a single lock can be built, the mountain must be removed. 400 million cubic meters of solid. Before a single lock can be built, the mountain must be removed. 400 million cubic meters of. That is 40 times the excavation volume of the Panama Canal. More rock than has ever been moved. Engineers propose 40,000 sequenced mountain blasts, a controlled demolition of an entire mountain range, conducted over 15 years. The removed material, 400 million cubic meters of rock, would need to be transported to disposal sites. This alone would But there is a second option: tunnel boring machines. The same technology used to drill the Channel Tunnel. The Channel Tunnel is 7.6 meters in diameter. A supertanker tunnel would need to be 200 meters across. There is a problem that no engineer has yet solved. 240 locks, each
The Panama Canal uses 82 billion gallons of fresh water every year, and it sits in a tropical rainforest.
One proposed solution: the world's largest desalination plant, built alongside the canal.
We've modeled the dependencies. Water impacts security, which impacts politics. Individually solvable.
Here is the deepest strategic paradox. You are building a canal to replace a choke point there, but every canal is itself a choke point.
Here is the deepest strategic paradox. You are building a canal to replace a choke point cause, but every canal is itself a choke point.
Iran's ballistic missiles have a range of 2,000 proposed canal diameters.
Security expert Colonel James Morrison. The more nodes of vulnerability you create, the more expensive the defense becomes.
A single supertanker, deliberately run aground in the canal, blocks all traffic, more effectively than any military.
The political dimension is equally complex. The canal must cross Yemen, currently the world's most active conflict zone. And even if the conflict ended tomorrow, the canal would require the cooperation of 4 sovereign nations, Saudi Arabia. The original 2008 estimate, $200 billion. In 2026 dollars, accounting for inflation.
For context, the entire Apollo moon program, cost approximately $280 billion.
The construction timeline, conservative estimate, 25 years, during which time the global energy transition.
The revenue modeling model requires a toll sufficient to justify the investment. $50,000 per transit, the 3 times.
That calculation assumes full utilization. It assumes no disruption. It assumes the geopolitical situation doesn't change.
And yet, the alternative is accepting a world where 20% of global oil can be held hostage by any.
There are 3 alternatives being actively considered. First, expand existing pipelines. The Hajar.
Second, the Saudi Petroline, 1,200 kilometers from the eastern province to the Red Sea port of Yanbu.
Third, the UAE Cross-Peninsula Corridor, 116 kilometers from Sharjah to Fujairah.
The UAE corridor can be expanded to 50 million barrels per day capacity. It would cost $10 billion, 1/5.
But the UAE corridor had one critical vulnerability. It runs through UAE territory alone. The fourth option, the one that no politician wants to say out loud, accelerate the energy transition. By
A timeline comparison shows the UAE corridor at 5 years, the energy transition at 20, and the mega canal construction.
If it were to be built effluent glacier, here is what the engineering blueprint looks like. Phase 1, the Saudi-Yemen segment.
Phase 2, the mountain crossing, 250 kilometers through the Hajar range. This is where the...
Phase 3, the lock system. 240 locks, each one individually larger than the Panama.
Phase 4, the port facilities. On both ends of the canal, new deepwater ports capable of...
The workforce requirement. The workforce requirement. At peak construction, 1 million workers simultaneously active on the canal.
The concrete requirement, enough to build 4 Great Walls of China. The steel requirement, enough to build engines. And then there is water, for the locks, for the workers, for the concrete mixing. In a desert that receives less than...
We have the technology to solve every individual problem in this project. The question is whether we have the political will, the financial resources.
California gasoline exceeded $5 per gallon. Global shipping rates tripled, and 30% of the world's traded fertilizers.
By late March 2026, selective reopenings began. China, Russia, India, Pakistan.
The 2026 crisis has done what decades of strategic analysis could not. It has made the cost of inaction visible.
The UAE has proposed an emergency expansion of the Cross-Peninsula Corridor, not the Grand Canal.
Saudi Arabia is simultaneously maximizing the petrolane, running at 7 million barrels per day, with expansion plans for 10 million.
The mega canal remains on paper, but the conversation has changed. In 2025, it was dismissed as...
So the question that engineers are actually asking in 2026 is not, can we build it? Well, we can. The question is...
3 Nishless. The Three Gorge Dam was called impossible until it was built. The Panama Canal killed 27,000 workers and faced...
The optimistic scenario. By 2030, a formal consortium of Gulf states, backed by sovereign wealth.
The scaled-down version. Not a full 240-lock supercanal, but a shorter, lower-capacity route. 5 million barrels per day doesn't replace Hormuz, but combined with the expanded UAE corridor and the maxed-out petrol... The realistic assessment. The mega canal, in its full form, will not be built. Regions. But a network of partial bypasses, pipelines, shorter canals, expanded corridors could reduce Hormuz.
The Hormuz Bypass Canal is not just an engineering question. It is a question about the future of global.
The Hormuz Bypass Canal is not just an engineering question. It is a question about the future of. The electric vehicle transition represents the technology route. If EV adoption follows current trajectories,
geopolitical analyst Dr. Fatima Al-Zahrawi, the canal debate reveals something important. The world has.
Meanwhile, in March 2026, the U.S. military began operations to reopen the strait. The same military power that cost the United States an estimated $30 billion per year to project into the Persian Gulf, more than the annual revenue of the canal would ever generate.
The terrain here is the fundamental challenge. We need precision.
We are aligning the technical expertise with the political will to make this happen.
Here is what the canal would mean if built. Every supertanker that transits length carries a cargo.
The 20 million barrels per day through Hormuz, that number represents heat in the winter, light in hospitals, food reaching supermarkets, medicines in pharmacies. Infrastructure at this scale is not about engineering. It is about the question every civilization must eventually.
The Hormuz Bypass Canal may never be built, but the question it poses about choke points, about
History rewards those who ask the impossible question. Whether the answer is yes or no, the asking changes the world.
This has been an analysis of one of the most audacious infrastructure concepts in human history. The engineering is real.
If you found this analysis valuable, subscribe to GenSecret Factory for weekly deep dives into the mega projects and mega factories reshaping our world.
What do YOU think? Should the world build the Hormuz Bypass Canal? Comment below with your analysis.
End card music. Next video previews.